Scheduling involves the timing of operations to achieve the efficient movement of units through a system. Chapter 15 addresses the issues of short-term scheduling in process-focused, repetitive, and service environments. Good scheduling means lower costs and faster and more dependable delivery. The strategic importance of scheduling is clear. Effective scheduling means faster movement of goods and services through a facility. Added capacity, faster throughput, and the related flexibility mean better customer service through faster delivery. Good scheduling also contributes to realistic commitments and hence dependable delivery. Scheduling deals with the timing of operations. Scheduling decisions range from years for capacity planning to minutes, hours, days, called short-term scheduling. The objective of scheduling is to allocate and prioritize demand to available facilities. Two significant factors in achieving allocation and prioritizing are the type of scheduling, which can be forward or backward, and the criteria for priorities. Scheduling involves assigning due dates to specific jobs, but many jobs compete at the same time for the same resources. To address the difficulties inherent in scheduling, we can categorize scheduling techniques as 1. Forward scheduling and 2. Backward scheduling. Forward scheduling is scheduling that begins the schedule as soon as the requirements are known. Usually used if tasks can be accomplished even if not meeting the due date. Backward scheduling is scheduling that begins with the due date and schedules the final operation first and the other job steps in reverse order. The correct scheduling technique depends on the volume of orders, the nature of operations, and the overall complexity of jobs, as well as the importance placed on each of 4 criteria. These 4 criteria are 1. Minimize completion time. This criterion is evaluated by determining the average completion time per job. Second is to maximize utilization. This is evaluated by determining the percent of the time the facility is utilized. Third, minimize work in process inventory, also known as WIP. This is evaluated by determining the average number of jobs in the system. The relationship between the number of jobs in the system and WIP inventory will be high. Therefore, the fewer the number of jobs that are in the system, the lower the inventory. And fourth, minimize customer waiting time. This is evaluated by determining the average number of late days. Scheduling process-focused facilities. These are production systems in which products are made to order. Items made under this system usually differ considerably in terms of materials used, order of processing, processing requirements, time of processing, and setup requirements. Because of these differences, scheduling can be complex. To run a facility in a balanced and efficient manner, the manager needs a production planning and control system that schedules incoming orders without violating capacity constraints of individual work centers, checks the availability of tools and materials before releasing an order to a department, checks work in progress as jobs move through the shop, provides feedback on plant and production activities, and provides work efficiency statistics and monitor operator times for payroll and labor distribution analysis. Whether the scheduling system is manual or automated, it must be accurate and relevant. This means it requires a production database with both planning and control files. 3 types of planning files are an item master file, which contains information about each component the firm produces or purchases. It also contains a routing file, which indicates each component's flow through the shop. And it also contains a work center master file, which contains information about the work center, such as capacity and efficiency. Control files track the actual progress made against the plan for each work order. Loading means the assignment of jobs to work or processing centers. Operation managers assign jobs to work centers so that costs, idle time, or completion times are kept to a minimum. Loading work centers take two forms. One is oriented to capacity. The second is related to assigning specific jobs to work centers. Let's examine loading from the perspective of capacity via a technique known as input-output control. This is a technique that allows operations personnel to manage facility workflows. It can be maintained by a system of con-WIP cards which control the amount of work in a work center. Also, we should consider Gantt charts. When used in loading, these charts show the loading and idle times of several departments, machines, or facilities. When used in scheduling, it monitors jobs in progress, indicating which is on schedule, ahead, or behind. Also, we should look at the assignment method. This is used for assigning tasks or jobs to resources. You can also use the 4 steps to add and subtract appropriate numbers in order to find the lowest opportunity cost. Once jobs are loaded, managers must decide the sequence in which they are to be completed. Sequencing specifies the order in which jobs should be done at each center. Priority rules for dispatching jobs provide guidelines for the sequence in which jobs should be worked. The most popular priority rules are first come, first served. This means the first job to arrive at a work center is processed first. The next priority rule is shortest processing time. This means the shortest jobs are handled first and completed. The next priority rule is the earliest due date. This is the job with the earliest due date is selected first. And the last priority rule is the longest processing time. This means the longer, bigger jobs are often very important and are selected first. Another type of sequencing rule is the critical ratio. The critical ratio is an index number computed by dividing the time remaining until due date by the work time remaining. As opposed to the priority rules, critical ratio is dynamic and easily updated. The critical ratio gives priority to jobs that must be done to keep shipping on schedule. A job with a low critical ratio, which is less than 1, is one that is falling behind schedule. A job with a critical ratio of 1 is on schedule. And a job with a high critical ratio, which is greater than 1, is ahead of the schedule and has some slack. An approach that minimizes processing time for sequencing a group of jobs through 2 work centers while minimizing total idle time in the work centers is called the Johnson's Rule. The Johnson's Rule can be listed in 4 steps. Step 1. All jobs are to be listed and the time that each requires on a machine is to be shown. Step 2. Select the jobs with the shortest activity time. If the shortest time lies with the first machine, the job is scheduled first. If the shortest time lies with the second machine, schedule the job last. Ties in activity times can be broken arbitrarily. Step 3. Once a job is scheduled, eliminate it. Step 4. Continue step 2 and 3 until chart is complete. Short-term scheduling is also called finite capacity scheduling. FCS overcomes the disadvantages of systems based exclusively on rules by providing the scheduler with interactive computing and graphic output. The initial data for finite scheduling systems is often the output from an MRP system. This output is traditionally weekly buckets that have no capacity constraints. MRP output is combined with routing files, due dates, capacity of work centers, tooling, and other resource availability to provide the data needed for effective SCS. Repetitive producers create forward-looking schedules with level material use. Repetitive producers want to satisfy customer demands, lower inventory investment, and reduce the batch or lot size with existing equipment and processes. A technique to move toward these goals is to use a level material use schedule. Level material means frequent, high quality, small lot sizes that contribute to just-in-time production. The advantages of level material use are lower inventory levels, faster product throughput, improved component quality and hence improved product quality, reduced floor space requirements, improved communication among employees because they are closer together, and smoother production process because large lots have not, quote, hidden the problems. Scheduling people to perform services can be even more complex than scheduling machines. Scheduling service systems differs from scheduling manufacturing systems in several ways. In manufacturing, the scheduling emphasis is on machines and materials. In services, it is on staffing levels. Inventories can help smooth demand from manufacturers, but many service systems do not maintain inventories. Services are labor intensive, and the demand for this labor can be highly variable. Legal considerations, such as wage and hour laws and union contracts that limit hours worked per shift, week, or month, constrain scheduling decisions. Because services usually schedule people rather than material, behavior, social, seniority, and status issues complicate scheduling. Scheduling services in the following businesses can be very complex. Hospitals may use a scheduling system every bit as complex as one found in a job shop. Capacities must meet wide variations in demand. Banks cross-train the workforce, which allows loan officers and other managers to provide short-term help for tellers if there is a surge in demand. Retail stores such as Target or Walmart track individual store sales, transactions, units sold, and customer traffic in 15-minute increments to create work schedules. Airlines face constraints while scheduling like a complex set of FAA work time limitations and union contracts that guarantee crew pay for some number of hours each day. 24/7 operations, such as emergency hotlines, police fire department, and mail order businesses, schedule employees 24 hours a day, 7 days a week. To allow flexibility, sometimes part-time workers can be employed. Cyclical scheduling with inconsistent staffing needs is often the case in services such as restaurants and police work. Here, the objective focuses on developing a schedule with the minimum number of workers. Other cyclical scheduling techniques, such as linear programming, have been developed to aid in service scheduling. There are 5 steps for cyclical scheduling. Step 1. Determine the necessary daily staffing requirements. Step 2. Identify the 2 consecutive days that have the lowest total requirements and circle these. Step 3. Make a new row for the next employee by subtracting 1 from the first row. Step 4. In the new row, identify the 2 consecutive days that have the lowest total requirement and circle them. Assign the next employee the remaining days. And step 5, repeat the process until all staffing requirements are met.